And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we see a low-speed coronal mass ejection, which is indeed Earth-facing. It came out of the southeastern portion of the solar disk, and that's why the title of our video yesterday was Coronal Mass Ejection Watch as the first portion of our title. So here's where it came from, down here in the southeast. You can see a little bit of an event happening there right there. You can see that. And we do see corroboration on other sources. We'll zoom in a little bit here. There you go. 304 angstroms view of that low-speed coronal mass ejection. Expected to take about 3 days to arrive at Earth, and not expected to cause much of a disruption of anything. Let's go out and look at the view from Lagrange point 5, the location of stereo A, which gives you a great view of that low-speed coronal mass ejection. You can see that little C-shaped appendage there. And there is still plenty of plasma in the corona for additional ejecta to occur. The sunspot that's risen in the southeast is quite small, but it is beta class. And you can also see Venus swinging around on the far side of the sun from the perspective of stereo A, again at Lagrange point 5. Here's the LASCO C2. This is at Lagrange point 1, in between the Earth and the Sun. And you can see ejecta on both sides of the coronagraph there, an indication that at least a portion of that coronal mass ejection is Earth-facing. Here's the LASCO C3, and you can see Mercury from that view. Again, not expecting it to be any sort of a big geomagnetic storm event. The 10.7 centimeter radial flux, currently at 83 solar flux units. And here's the Enlil spiral, expecting the coronal mass ejection strike to happen on the 15th. So again, no big deal there. It's a low speed and fairly low density coronal mass ejection, it looks like, as well. And next we'll take a look at the colorized magnetogram here, an animation of it. Another SDO video. This is in the Browse Data section if you want to look at this yourself. It's on the SDO website. Again, that sunspot in the southeast there is beta class, but it's quite small, and we'll show you intensity grams in high resolution by the end of the video. We've also got some great helioviewer movies, as we usually do, and here is the 94 angstroms SDO video. And before we get into more of those, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smAshomash. We've got the Ulta meme will be coming out later today. Our patrons would have already seen that if they joined at the $3 per month or more level. Here's one more of our helioviewer movies. South Pole coronal hole very much in view there, as well as a coronal hole in the north. We'll show you more in-depth analysis of that also later in the video, when we start looking at magnetic data from the National Sunspot Observatory. Today we'll make another Smash Lights video as well, although today's may not be as over-the-top as yesterday's. Check out our playlists at youtube.com/smashomash/playlists. The Smash Lights segments are part of that. And it's when we talk about whatever we want. The latest subjects have been news, politics, and COVID-19. We'll be streaming live at the moment of the solstice, probably to be the first channel to wish you a happy solstice, whether you're in the southern hemisphere, and we do have viewers from down there, by the way, or in the north. Just over a week of fall left in the Northern Hemisphere. Make sure you join us at 5:02 and 20 seconds Eastern Standard Time on December 21st, the moment of the solstice. And again, that will be a YouTube live stream exclusive. Thanks to our new subscribers over at YouTube, youtube.com/smAshomash. And don't forget to check out our other playlists like smAshomash.org presents the sun. We're also on BitChute. Thanks to our new subscribers over there. We're currently streaming live to Twitch because it's such a great platform. Twitch.tv/smAshomash. Thanks for people leaving comments about that. And we've changed things up a little bit here and reduced the amount of auto hosting. So we won't have as many kids randomly playing Call of Duty or something like that on our channel. We've gotten rid of that feature. Twitch.tv/smAshomash. They've got a great mobile app as well, by the way. And we've also got a Discord server. Check out smAshomash.com. Visit all of our social media links. And help to support the channel via sharing the content on your social media links. And again, we'll be producing another Smash Lights segment today. It'll be a YouTube exclusive live stream once again. Will we have a caller? Who knows? It could be. And let's move on to a cosmology segment. Since space weather's kind of calm, we'll talk cosmology for a brief second. First of all, when it comes to cosmology, perspective is everything. So when looking at a galaxy, your perspective has a lot to do with how that galaxy looks. If you're viewing it from this perspective, it will be a blazar. If it's from this perspective, it'll be a quasar, perhaps. Where you're looking down the poloidal field jets, that would be, those are the poloidal field jets that I'm drawing in there. If you're viewing it as an edge-on disk, it will appear as a radio galaxy, such as Cygnus A, which we feature on the website, and on our clothing, which you can link to that also if you want to purchase any merch. You can link to the Smash store and the smAsho store at smAshomash.com. And don't forget to enter the promo code SMASHO on all orders at checkout through Christmas to save 10% on said orders. So perspective is everything, folks. If you're viewing it somewhere in between where it's a radio galaxy and where it's a quasar or blazar, it'll appear as an active galactic nucleus. And so just a little tidbit there about sort of why galaxies appear the way they are. Now we're going to do a dice throw. We're going to pick a random number between 1 and 1031. It's essentially a 1031-sided quantum die. Why? Because at the Neil Gorell's Swift Burst Alert Telescope X-ray Observatory, there are 1031 entries. So let's see what we get this time. Today's quantum random number is 353. So we're going to scroll down the list and look at a random object here. 353 is a BL Lacertae object, which is another type of galactic nucleus, an active galactic nucleus. This is one that has a full spectrum of photonic emissions. Pretty much the full range is what you'll see in a BL Lacertae object. It's, I guess it's somewhere in between an active galactic nucleus and a radio galaxy. This one's PKS 1057-79. There are the X-ray transients from it, and it's quite a consistent X-ray source, as you can see here in the historic graph. Let's take a look at it on Sinbad. Galaxy PKS 1057-79, a BL Lacertae object. Here it is on Sinbad. Not very exciting there. Let's look at it on Aladdin Light and see if we can get a little better view here. We'll look at it on the Chandra X-ray telescope. Not showing up in X-ray. How about XMM Newton? Nope. How about on the 2MASS? So there you go. It looks like a pretty distant galaxy. I won't spend a lot of time talking about galaxy. This is listing it as a quasar, but in any case, 1057-79, a BL Lacertae object. We've also got a cosmology forum at the forums, so feel free to check that out. Post your favorite cosmology subjects, as well as if you'd like to talk about Earth and geophysics or charticles. And thanks, Nebo J. Again, check out smashomash.com. All the social media links are there. The smAsho store and the Smash store, and the forum is all linkable there, as well as our first 9 smAshomash.org presents the sun videos. If you haven't checked those out, it's a bunch of close-up stuff. And you can also view our mission, if you like, at smashomash.com/forum/mission. I won't get into reading it today, but number 1 is to assist, study, and report on the ongoing formation of a unified theory of physics. So get involved there before I vanish. And that's the end of today's cosmology segment. Let's move on to some more current space weather data, such as the real-time solar wind. We'll get to it. I just want to check the life of the stream first real quick, and we are good. So let's get back to the real-time solar wind, a regular feature daily at the Smash News Network. So here we've got solar wind density of quite low here, less than 4 protons per cubic centimeter. Solar wind speed down to background levels, basically at 361 kilometers a second. The BTBZ has recently moved the BZ into positive territory there in the last, say, 6 hours. Pretty uneventful. KP index, a measurement of global geomagnetism, down to 0. And here's 4 hours of data of what the magnetosphere might look like according to the Space Weather Modeling Framework. And this data courtesy University of Michigan. And I would remind our viewers to please share the content on your social media. And we greatly appreciate when you do. Here are the ground magnetic perturbations over the past 4 hours. And we see some over the Canadian North Pole, as well as extending down into the Pacific Ocean there toward Hawaii. And you can see some evidence of the South Geomagnetic Pole being in the southern Indian Ocean instead of over the Antarctic continent, thousands of miles from the geographic South Pole. The proton flux has remained mostly flatlined here, a tiny little uptick there, but not really worth commenting on. And we don't see any major solar flares, just a series of B-class flares, most likely emanating from sunspot 2792, the new small sunspot that's recently risen in the southeast. If you're up before dawn, you may see Venus, the 3rd brightest object in the sky, my favorite planet, at a magnitude of -4.0. I like to use in-the-sky.org. Shout out to in-the-sky.org. Drop me a line. We'll do a video just about your website. And I like to use theplanetstoday.com for my solar system diagram. Here's where things are now. And there's where things will be in a week. The GOES magnetometer has a very low spike in it there. Actually, it's not super low, but you can see that little spike there at the bottom of the graph. Nothing to write home about. And let's see what's going on in the current sheet. And here's the top view, ecliptic plane field plot. And you can see the Earth is solidly in the North Pole current sheet here. I don't know why it's stopping. Let's reload that, see if it works. There we go. Earth solidly in the North Pole current sheet, although an indication that the South Pole is still quite strong here, and perhaps an indication that that sunspot is going to degrade quickly. Don't be surprised to see that sunspot evaporate as quickly as it rose. In any case, it looks like the Earth is approaching a South Pole-oriented current sheet, shown here in red. Here's the line-of-sight coronal hole field plot, which is also stopped because reasons. And we'll just refresh that. Keep in mind that data is 1 hour and 18 minutes old, and the magnetic environment can suddenly change. And it looks like the coronal hole that's visible in the north is North Pole oriented here. This also shows you the B field in blue. And there's a line of sight field plot. We don't need to refresh that. Here's the magnetic field plot of the solar corona, the sun's atmosphere. Quite a chaotic system it is. And it's showing you open potential field force lines in black or purple if they're coronal hole associated, and closed potential field force lines in pink. PFSS stands for potential field surface source. And let's get back to some more data here. We don't see a lot of charging hazards. Electron flux is at fairly nominal levels. And just give that a moment to display. Again, we are streaming live. A regular feature of the Smash News Network. No, that's okay. We'll wait. And it looks like we're seeing some technical difficulties here associated with Solon.info. Let's move on to that was the 1-year chart of electron flux that we could not display there. Let's move on to the Electron Forecast. And NOAA's forecasting an uptick here in the electron flux. I would tend to agree with that. That is not even warning levels, though. There's the 3-day chart. Not a lot to report on when it comes to electron flux. Here's the total electron content forecast, showing you the full air column. We see some minor anomalies here over North America, as well as small anomalies there around Antarctica. No big deal there. And next we're going to look at the ionosphere. There are some diagrams of where stuff is located. And we like to show that daily to help remind our viewers. There's the ionosphere layer, and it's looking a little anomalous to me here. So we're showing you a full day of the ionosphere, and the sun is just ahead of the most heavily charged zones there. Typically, we see some nighttime charge-ups in the southern hemisphere, quite far south actually. And I'll let that play through one more time, and then I'll bring up the latest image. By the way, this map does show you the South Atlantic anomaly, sort of the weakest point in the Earth's magnetosphere. There's also a very weak point approaching South Africa. In any case, here's the latest image. That one is from 10:30 Universal Time. And you can see pretty heavy charging here in the southern hemisphere. Next, we'll look at volcanism at volcanodiscovery.com to see Kluchevskoye still erupting. 23,000-foot ash plume as it explodes. Karimsky also exploding. Me vanishing. So the Kamchatka Peninsula quite active with volcanoes here. Karimsky is producing a 13,000-foot ash plume. Suwanosejima near Japan producing a 6,000-foot ash plume. Mount Ibu exploding. Similarly sized ash plume there at 6,000 feet. Sinabung showing some incandescent avalanches, and about a 3,000-foot plume above that. Please don't pole vault the caldera. Sinabung, the deadliest volcano. One of 2 deadly volcanoes, actually. White Island volcano north of New Zealand killed some people in the past year also. Tokono exploding, flight level 7070 over Tokono. It's a 7,000-foot ash plume. Santiaguito, some pyroclastic flows there. Don't build a campsite on the lower slopes of Santiaguito. It could make for a bad day. Strong ashfall and fine particles. And volcanic ash extended about 15 to 20 kilometers to the southwest of the volcano. A little bit of volcanic snow falling there. Also blocking ash flows. Oh, a gravitational collapse of the Caliente lava dome as well. Not sure the altitude of the ash plume above that, if there is one. Pacaya A new eruptive fissure vent opened and a new lava flow. So it's a volcanic uptick, folks. Fuego exploding, flight level 150. It's producing a 15,000-foot ash plume. Revenador exploding, 14,000-foot ash plume above that. And Sabancaya is exploding, 24,000-foot ash plume above that. Please don't fly your ultralight aircraft over any of the calderae. It could be unhealthful. We see some deep quakes kicking up over the past couple of days here, such as this 4.6, which happened yesterday at 12:38 Universal Time. It's a 4.6 in the Bali Sea. That 4.6 magnitude quake at 276 kilometers deep. 4.6 also striking Vanuatu. Only about 12 minutes later, also at depth. That depth, 134 kilometers. So two quakes very close together there at a similar magnitude and a totally different depth. One of the larger of the past 24 hours, maybe the largest, is this 5.2 in Indonesia, also at depth, 106 kilometers. It happened at 15:55 Universal Time. There's a deep one at Timor-Leste, a 4.3 at nearly 200 kilometers depth at 18:58 Universal Time. So once again, folks, the earthquake drought continues here. We're seeing a drought, a massive drought of 6, 7, 8, and 9 magnitude earthquakes. I think the largest of the past 24 was this 5.2. Let's move on. We don't want the video to be too long. And check out all the low pressure systems there over the Pacific Ocean. No less than 5 low pressure systems there. And let's advance. That's actually, yeah, all right, there's where we are now. And here's where we expect it to be via the GFS forecast tomorrow at noon. There's where we expect things to be tomorrow at noon in terms of pressure. Quite a significant low pressure there south of Iceland as well, and some high pressure there over the North Polar region. We'll look at it on nullschool.net momentarily. So let's just take a look at surface winds here real quick. There are the surface winds of the North Geographic Pole. And here's the jet stream scenario for the north. Quite a chaotic series of jet streams there. Here are the jet streams of the south. And we'll show you the east. We'll show you all 4 corners, folks. There's the east. Looks like a low pressure ridge there off of the east coast of Australia. Shout out to Kimberly. That one's pretty close to your neck of the woods. And here are the jet streams of the western world. And you can see some cold air being injected into the central U.S. out of Canada. Is there lightning striking? Well, indeed there is. Let's zoom in. Hey, Wichita Falls. Hey, Granite. I think it's calmed down. I don't see any fresh strikes coming in. I like to use lightningmaps.org when I hear thunder. That way I can convince my foes that I'm Thor and or Odin and that I'm causing the thunder and lightning to happen. And here's a GO 16 lightning map where you can see some lightning strikes there, some significant ones over, indeed, southwestern Oklahoma. Next, look at the U.S. Doppler radar map. Now we're going to show you how the snow forecast has changed massively since yesterday. And we talked about how a 6-day forecast is ridiculous and you probably shouldn't be alarming people about things if you don't know anything about meteorology. And perhaps we'll do more meteorology videos in the future. Heavy snow there over portions of the Texas Stovepipe and the Oklahoma Panhandle. And here's the forecast I was talking about. It's at Tropical Tidbits. I'll blow that up a little bit. And notice how we're not getting a forecast for 2 feet of snow over eastern Pennsylvania anymore. Now just a couple of inches are forecasted. Whoops. So there's the new forecast through Thursday, December 14th. Looking at more like 3 inches where I'm located. And we'll keep you posted on that one, as there's been a lot of YouTube channels talking about that snowstorm. So a massive reduction. It looks like it may be going out to sea more quickly than expected. Here's what's going on in the cloud layer currently. We use the shortwave radiation satellite to see clouds when you can't see clouds on the visible. It's a 3.9 nanometers radiation map, really. And here's what's going on in the water vapor. And we'll zoom in on Oklahoma there to give you some idea of when your extreme weather will come to an end. So let's zoom in on the Texas Stovepipe there on both maps. And this will give you a better idea of what's going on if the Doppler radar is not being helpful. So there's the cloud layer. There's the water vapor map. And that dry mass of air is taking its good old time here. This dry air mass right here is not exactly speeding things up. There's the water vapor, and there's the cloud layer. And it's mainly being caused by compression from cold air from Canada once again. And it's time for bonus features. We're going to show you a close-up of the sunspot, 2792 that is. We're going to show you the colorized magnetogram. And then we're going to show you the rest of our HelioViewer videos. Just give me one moment. And there's that colorized magnetogram. Looks like there could be another sunspot rising right there. There's sunspot 2792. Again, don't be surprised if that thing evaporates. Although it could just be South Pole strength. So that looks like it could already be an umbra, folks. I'm going to call it and say that's going to be sunspot 2793. Here's sunspot 2792. It's beta class. There is a significant possibility for C-class solar flares. Probably nothing bigger than that. Again, don't be surprised if it suddenly evaporates. Help the channel not to evaporate by sharing the content on your social media as we close things out with some additional videos of the local yellow dwarf, such as the 304 angstroms full disk view, as well as some zoom-ins of the southern hemisphere. So here we go. Thanks again for tuning into the Smash News Network. Least busted name in news. Here's 171. And again, we've got some close-ups in 304 and 171 angstroms, which are, by the way, part of the UV spectrum. So when we say 304 and 171 angstroms, we're talking about very narrow bands of emission spectra. This one is the emission spectra of ionized helium. And the next one is the UV emission spectra of ionized iron, one of the many ionized states of iron. As for iron to be stable, it needs to have a lot of electrons. And this is something like 17 times ionized iron. Iron that really wants lots of electrons, yes. So anyway, thanks for tuning in, folks. Remember, stare at the sun, don't drink it. If you do, don't drive. Please don't drive. And since it'll never be now again, may that solar wind be at your back. And this video present on your social media news feeds.